9.3 Part 2. Example 5. What is the second term of this geometric sequence? Okay, so I'm starting with a 2, then I have a missing term, and 128. Okay, so I'm going to go through two different methods of how to figure this out. Method 1, I just rewrote the sequence, and if this is geometric, that means that we're multiplying by a common ratio. So I'm starting with 2, and to get to my next term, I had to multiply by some number that we're calling r. And then to get from the second to the third term, we had to multiply by r again. To get from the third term to the fourth term, we had to multiply by r again. So now I'm going to write an equation to represent this. I'm starting with 2, and then I multiplied by r 3 times, so that's r cubed, and I end up with the value of 128, so it's equal to 128. What we're going to do now is solve for r, and I'm going to do that by dividing both sides by 2. So these 2's are going to cancel, and it leaves me with r cubed is equal to 128 divided by 2 gives us 64. To get rid of the cube, I'm going to take the cube root of both sides. So the cube root and the cube cancel, and the cube root of 64 is 4. So your ratio is 4, which means to get from term to term, we're multiplying by 4. Okay, so to find the value of the second term, a sub 2, I would take the term before it and multiply by the common ratio that we just found. So 2 times 4 gives me 8. The second term is 8. And just for fun, you could see what the third term is. So if this is 8, we would multiply 8 times 4 to get 32. And then just to make sure that it really works, you could multiply 32 by 4 again and make sure that you end up with the 128. Okay, method 2. You could substitute into an explicit formula. Okay, because I know the value of my first term, a sub 1 is 2. And this is the first term, second term, third term, fourth term. So a sub 4 we know is 128. And the number of terms that we're dealing with is 4. So I could substitute the pieces that I know into the explicit formula. So 128 is equal to the value of my first term, which is 2. We don't know the ratio. And I could substitute for n 4. 4 minus 1 gives us an exponent of 3. Okay, so we're going to solve for r. In order to solve for r, I'm going to divide both sides by 2. So these 2's would cancel, and then we have 64 is equal to r cubed. Take the cube root of both sides, and we get 4 is equal to r. So once you know your common ratio is 4, you can do 2 times 4 gives you the value of the second term, which is 8. And again, you can multiply by 4 times 4. It works. Okay. Example 6. Similar problem to the previous. What is the third term of the geometric sequence? Okay. So I have 2 blank blank negative 54. The difference between examples 5 and 6 is that number 6 has a negative term. Okay, so again, I'm going to work through the two different methods. Method 1, we start with a 2, blank, blank, negative 54. Every time we're multiplying by an r. So I'm just going to write my equation, starting with 2, and I multiplied by r 3 times, so that's r cubed is equal to negative 54. We're going to solve for r, the common ratio, by dividing both sides by 2. These 2's will cancel. So now it's r cubed is equal to negative 27. we'll take the cube root of both sides. The cube root and the cube cancel, and the cube root of negative 27 is negative 3, which means we're multiplying by negative 3 to get from term to term. Okay, so that's what I did here in order to find the value of the third term. My first term was 2 times negative 3 gave me my second term of negative 6. But then when I do negative 6 times negative 3, negative times a negative creates positive 18. Positive 18 times negative 3 gives us negative 54. So when your ratio is negative, every other term will be negative. Okay, we're going to work through example 6 using method 2, substituting into the explicit formula. The value of my first term in the sequence was 2. The value of the fourth term in the sequence was negative 54. We're looking for the ratio, and the number of terms that we have is 4. So I'm going to substitute. This is your a sub n, which is a sub 4, negative 54, is equal to the value of the first term times the ratio, which is what we're looking for, raised to the 4 minus 1 power. 4 minus 1 is going to give us an exponent of a 3 here. Then you'll divide both sides by 2. Take the cube roots, and we get negative 3 is r. From here, you would just solve the same way we did before. 2 times negative 3 to get negative 6, times negative 3 to get positive 18, times negative 3 to get negative 54. Okie dokie. Example 7. A geometric mean is the middle term of 3 geometric terms. Okay, so here's my geometric sequence. I'm starting with 3. We have a missing middle term and 48. My geometric mean would be this number in the middle. I want to figure out what that number is. So 3 times some number gives us the middle number, times that same number gives me 48. I'm going to write an equation. Starting with 3 times r squared is equal to 48. To solve for r, we're going to divide both sides by 3. Your 3's will cancel here. 48 divided by 3 leaves me with 16. So r squared is 16. Now something special is going to happen here. In order to get rid of the square, we would take the square root of both sides. Don't forget, when you take the square root of both sides, you need a plus or minus. So the square root and the square cancel, and you're left with plain r is equal to plus or minus 4. So your ratio could be positive or it could be negative, which means the geometric mean could be positive 12 or it could be negative 12. Example 8. What are the missing terms of the geometric sequence? All right, so now we've upped our game. I've got 5 terms, 1, 2, 3, 4, 5, and 3 missing terms in between. I'm going to set this up using method 1, where I have my first term times a ratio times the ratio times the ratio times the ratio gives me a value of 16. So when I write my equation, I started with 1, and then I multiplied by the ratio 4 times, so that would be r to the 4th power is equal to 16. To solve for r, we would have to take the 4th root of both sides, and when you're taking the square root or the 4th root, if your index is even, we're going to have to do the plus or minus. Okay, off to the side, I broke down 16 piece by piece, in case you guys forgot. 16 can be broken down to be 2 and 8. And then we can break down 8 to be 2 and 4. And 4 can break down to be 2 and 2. So 16 is 2 to the 1, 2, 3, 4th power. 2 to the 4th. So if we took the 4th root of 16, or the 4th root of 2 to the 4th, that leaves us with 2. So your ratio for this problem could be positive 2, or it could have been negative 2. So to fill in the missing terms, we could start with 1. And if the ratio was positive 2, then my next term would be 2. Times 2 gives me 4. Times 2 is 8. Times 2 is 16. So that works. Or if the ratio was negative 2, we would have started with positive 1 times negative 2 gives me negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Okay, so that would also be an option. Example 9. All right, so this is where we're starting. We're going to write an explicit formula for the geometric sequence given the value of the 4th term and the value of the 7th term. Oh, I'm lying. They're fractions. Oh no. Okay, so we still have the value of the 4th term and the value of the 7th term, but now they're fractions. Sorry. In order for us to write the explicit formula, I can't stop laughing. We're going to need the value of the 1st term times the value of your ratio. And I don't know those things. So we're going to do step by step. I will write out what this pattern would look like. Okay, so 1st term, I don't know. 2nd term, don't know. 3rd term, I don't know. The 4th term, we do know. It's 8 over 81. We're missing the 5th term, the 6th term, and we know the 7th term is 64 over 2,187. So what I want to do first is find that ratio. What number am I multiplying by to get from here to here to here? Okay, so we're starting with 8 over 81. And then I'm going to multiply by the ratio cubed because we had to multiply 1, 2, 3 times. And that gives me 64 over 2,187. All right, solving for r. If I want to get rid of this fraction here, I can multiply both sides by its reciprocal. So I'm going to multiply by 81 over 8 here and here. Okay, so the 81 over 81 would cancel, and the 8 over 8 would cancel. So we're left with r cubed. And if you put this into your calculator, you're going to get 8 over 27. Now we're going to have to take the cube root of both sides. When we do cube root, you don't have to worry about plus or minus. Okay, so if it starts positive, it's going to end positive. The cube root of r cubed is going to just be r. And the cube root of 8 is 2. And the cube root of 27 is 3. So your common ratio is 2/3. Okay, so that's what we're multiplying by to get from term to term. Now that we have r, we're going to find a sub 1 by substituting a sub 4 and n into an explicit formula. Okay, so this was my 4th term. The 1st term, I don't know. R, we just found, was 2/3. N, since I'm using the 4th term here, N is 4. Four minus 1 gives us an exponent of 3. I'm going to cube the 2/3. So 2 cubed gives us 8. 3 cubed is 27. I want to find a sub 1. So to get rid of the 8 over 27, we're going to multiply by its reciprocal. Okay, so I'm multiplying both sides by 27 over 8. The 8s would cancel, the 27s would cancel. So now you've got a sub 1 by itself. And when we multiply here, you're going to end up with 1/3. So the value of the first term in the geometric sequence is 1/3. Now it's time to substitute the value of the first term and the value of your ratio to write the explicit formula. So this is the value of our first term, and this is the value of the ratio. Explicit formula is written. If you were to write the formula for the recursive formula, we would have to substitute the value for r and state that the value of the first term is 1/3. Are we done? Yay, we're done. Okay, so you have another Math Excel assignment. It's 8 questions. Both of your Math Excel assignments for this week are due Sunday by midnight. If you have questions, email me, and have a good day.